In grade 10, they gave you this, f of 3. I'm so glad that this blue box is joining us. That's great. If they gave you f of 3 in grade 10 is where we started learning about functions. Okay, what did that mean?
X equals 3.
X equals 3, we input it, we get an output, and we actually got a coordinate on the graph of f. Yes?
Yeah.
Okay, so if my f of x was x plus 6, we would now get 3 plus 6 equals 9, and I got a new coordinate. The answer is 9. That is my output, but I actually got a coordinate as well, 3, 9 on the graph of f. Yeah?
Yeah.
Then your teacher also gave you something like this. They could go a graph like this, right? They could give you an actual graph instead of giving you the equation. They could give you a graph, and they could say f of 0. And what would you tell me the answer is?
X equals 0, so x equals y intercept, which is 5. 6.
Nope.
F of 0 equals 6.
Equals
Well,
a
there's
6.
just lines, I guess. I thought that was right.
You guessed wrong.
Then you get 6.
Well, no, I just didn't count the lines.
Okay. So we would get 6 till its coordinate at 0, 6. Yes? Input, get an output. That's what we do every single time you're getting a coordinate on that graph, right? Then, say your teacher gave you this, f of a. And then you were all like, I hate you. That's what you're thinking in your heads. But really, your teacher wasn't making anything harder. What does that mean? X equals a. So I get a plus 6. That's it. That's all your teacher was doing for you. So now we get to grade 12. What if I say this? F of x minus 3.
X is x minus 3.
X equals x minus 3, right? So this is going to get ripped off my board, thrown away, and replaced with x minus 3. So I'm going to get x minus 3.
In brackets.
You could put it in brackets, but if there's no 1 in front, you don't have to, or a number in front. And then what do we have at the back?
Plus 6.
Plus 6. So do you see I just replaced this black x minus 3 with the x? And I got x minus plus 3. Nothing crazy, right?
Nope.
Do we agree?
Yeah.
Okay, let's go back to composition, which is actually just this. This is composition. You just didn't even know you're doing composition.
Yeah.
As hard as this question is here, is composition.
I don't.
So let's go back.
It's like composition.
So here we have composition of function. I don't know why. Function. Okay. So, same thing. I'm just going to give you an f and a g function, and then we're going to get to the step of where we just were. So, trust me. I don't not teach you, so trust me that this will work. Okay? Don't panic. Throw the panic to the side. We don't need it here. 2x plus 1 is our f of x. Our g of x is x squared plus minus 7. Okay? Haven't taught you anything, so you should really be panicking that you don't know how to do this. Because I haven't even taught you how to do it. People are like, oh, I haven't taught you anything. I'm sure you'll be okay. All right. So, I literally just made you write down f of x and g of x. Yes? That's all I did. We agree? Okay. Over here, I have f of g of x. Yes? F of g of x, that's how we say it. Do I know what g of x is? What is it?
X squared minus 7.
Cool, let's write it down. So equals f of x squared minus 7. Are we at the exact same step as where we just did the last question? I gave you what was in the brackets. What do we do with what was in those brackets? You put them in for the x in f of x. Right? And what is f of x? 2x plus 1. So now I'm going to get 2, replace the x, plus 1. Right? So I'm going to get 2. What's my x going to be?
X squared minus 7.
X squared minus 7. And then what?
Plus 1.
Plus 1. Is that crazy? No. I'm just taking x, instead of replacing it with a 3, right, which is what we were doing for the last 2 days, replacing it with a 3, I'm now just replacing it with g, whatever the heck g is. So I'm taking this and we're putting g in it, right? That's all I'm doing. So then I just get 2x squared minus 14 plus 1, which is 2x squared minus 13.
First you get x squared minus 7, otherwise you're solving for 0.
I'm not solving for anything.
Yeah, you're solving for f of x.
I didn't put it equal to 0. I'm not solving for anything. I gave you f of g of x equals this, equals this, equals that, equals that, equals that. So this equals this. Don't have to. Because this equals this, equals this, equals this, equals this, equals this. So this is the same as the first step. Yeah.
If you break the x squared minus 7 equals...
You wouldn't write that. You would write f. If you want to write a solution at the end, a finalized solution, you write this equals that. Because that was my question. But you don't have to. But if it stops you from putting a 0 in, you can. But this is ultimately what you found. Right? That's a middle step. F of x squared minus 7. That's a middle step in this whole question. This is equal to this, ultimately. Okay, g of f of x. Now I'm plugging in f of x this time. So I'm getting g of 2x plus 1. And then what am I doing? I'm putting 2x plus 1 in for the x's in g. G is x squared minus 7, correct? So now instead of x, I'm going to put in 2x plus 1. Will you agree? Into this function here, x squared minus 7. So now I'm going to get x squared minus 7. But instead of x, what do I have? 2x plus 1. Because I'm putting 2x plus 1 in for all the x's in g. Now what do I do when I have a squared?
Plus 1, 2x plus 1.
You rewrite it twice, every single time. If you don't, you're going to tell me it's 4x squared plus 1 and it's your middle term. So if I ever have a binomial squared, this is not the time to save pencil, I would rewrite it twice. So I get 4x squared plus 2x plus 2x is plus 4x plus 1 minus 7. So I get 4x squared plus 4x minus 6. So technically, g of f of x equals 4x squared plus 4x minus 6. I did write it on the other one, Kyle. Just took a little nap ski in the middle there, or what? You missed that one.
I did the other one before you did.
Okay. Now the domain and range off of these, you would just get your function, you could find the domain and range. Nothing along the lines ever caused any problems. There was no restrictions on the graphs. The original graph was an XCR, the bottom one was an XCR, and this becomes an XCR. But what happens if we get like a radical embedded? So, let's try this one. So I'm going to give you f of x equals the square root of 4x minus 3. And g of x equals x squared minus 4. And I want you to give me f open dot g of x. And then I want g open dot f of x. And I want the domain of each. Go. So here we have to rewrite it as f of g of x. Then we put g in, so we get f of x squared minus 4. And then we're going to get the square root of 4 times x minus 3. X just happens to now be what? X squared minus 4. So I literally take f, the function of f, and I put brackets where x would be. and then input my function. Right? That's all I'm doing. Nothing crazy. Everyone agree? That's all I'm doing. I'm rewriting this f function, but instead of having an x and putting brackets, then I can put my stuff in. So I get square root of 4x squared minus 16 minus 12. That's a lie, minus 3. I got really distribution happy there. We go boom, boom. So we get 4x squared minus 16 minus 3. So I get the square root of 4x squared minus 19. Now, my domain is going to be based off of my radical, correct? What's under your radical, unless your radical's in the denominator, and be prepared for Thursday to have a radical in the denominator. If your radical's in the denominator, it can be greater than 0, but it can't be equal to. Remember that? You can't equal 0 in your denominator. So if I have a radical sitting in a denominator, do not write greater than or equal to. It's just greater. This one's not in a denominator, so I would go 4x squared minus 19 is greater than or equal to 0. 4x squared is greater than or equal to 19. X squared is greater than or equal to 19 over 4. Square root, when I take the square root with my hand like this, what do I have to remember to do? Plus minus. So I get x equals, or sorry, it's greater than or equal to positive or negative
19 over 4 squared.
square root 19 over 2. But you have to watch yourself. Because these actually, the inequality sign doesn't work the same with a squared. You're going to have one that's greater than 19 over 2 and one that's less. Type that into your calculator. Type it in. It'll be less then. No, it'll work. It just has to be less. Type it into your calculator.
Now y equals?
Yeah, into your y equals and look at it.
Why are you able to do that? Or you only
Type it into your
square the
calculator.
bottom function up?
Yeah, you can split square roots up. I told you about that in grade 10. You were taught that if one of them is a perfect square, one of them is not, you can split the square root up. I taught that in grade 10.
Would they, if this is like an answer that test, would they have square root of 19 over 4 and then square root of 19 over 2?
They'll have 19 over 2 like I have. All right. You can't give both. Both are correct. So you can't give root 19.
Can't they usually say like, oh, just the more?
You're not going to say the more correct. That doesn't happen in math. I'm like the more simplified. Okay, if you look, when I just do linears, and you guys were taught this last year in absolutes and stuff like that. When you do linears, you get like x is greater than 3/4, and you're done, right? Greater than or equal to. But when you do quadratics, you have to watch yourself. You can't just solve it like this and say that's the answer. If you look at your calculator, one of these will actually be less and one of them be greater. So it's actually x is less than or equal to negative root 19 over 2. And or x is greater than or equal to root 19 over 2. The graph goes in opposite directions, doesn't it? So you have to watch yourself when there's these squareds in it and you're solving it like this. This is not going to actually give you the right answer. It'll get you the answer, but you have to watch yourself. Sometimes it's between the two values, and sometimes it's greater. And if you look at your calculator, it will help you see the graph, right, to know what it would be. So my domain is actually x such that x is less than or equal to root 19 over 2, or x is greater than or equal to root 19 over 2. X and L in the reals. Now, there's sometimes where your radical doesn't actually cause problems. Sometimes your radicals don't end up with a restriction. So, side note. We'll come back to this in a second. If I had instead given, say this was it, 14x squared plus 19. Say that was the oopsie. Say the difference was it was a plus 19 instead of a minus 19. Okay? Is there any x I could fill in here that would cause me problems? Let's think about it. Problems happen when I get a negative under my square root. Yes?
So 0.
So 0
No.
would get me 19. So is that a problem? No.
Negative.
Oh, it's plus.
Negative 19?
Negative, what? I'm not replacing numbers. I'm replacing x. I can't just make 19 be negative 19. What could I put in x that would cause me problems? It's a trick question. Nothing. I can't put anything in it. Anything I put in here will make it positive. -1 is positive 1. -16 or -4 is positive 16 times 4 is positive positive. I'm not going to get any negatives. I literally can't. So the domain on this one is XCR. That was one that doesn't have a restriction. So you have to watch yourself. There are special cases where radicals don't actually have problems. There's not a number in the world that I can plug into X that when I square it will make it negative and make this be negative, right? Nothing is a problem. So when it's an addition of squares, it's usually not an issue. Okay, this one, I have to do g of f of x. So I'm going to get g of square root 4x minus 3, which means I have to plug this in for the x of g. So I'm going to get g, which is x squared minus 4, right? That's what g is. But it's not going to be an x now. What's it going to be? Square root 4x minus 3 gets put in for all my x's and z's. This question is done terribly, just so you know. Star, 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 star. Not because the question's done terribly, but because you give me the wrong domain. Did this equation have a radical in it? Does this equation currently have a radical in it?
No.
That doesn't have a radical in it?
Yeah, it does. But
It does.
E is equal to 4x minus 3 to be squared.
Does this equation currently have a radical in it?
Yes.
Yes. Not the next step. Does this equation have a radical in it? Yeah. And when you have a radical in an equation, you could get restricted domains, right? So I have to, this will become, yes, this will become 4x minus 3. The squares will cancel, minus 4. And my answer is 4x minus 7. That is true. However, you need to follow behind with a restricted domain. Type this one into your calculator, 4x minus 7. Type it in. Just type it into your calculator. I want you to see it. Does everyone have 4x minus 7 into your calculator? I'm not doing this because like you don't know what that looks like. Write it into your calculator. Type this into Y2. If you have colored calculators, cool. If you have normal calculators, you need to go over to your Y2 and make that line thicker. Remember how to do that? Go over to the slash line and hit enter once in your Y2. So type this one into Y2 and make your line thicker.
Just -4 the whole thing.
The entire equation.
Oh,
Just -4, Tegan.
it starts at negative.
Then press graph.
Hey, that's another question. The arrow is pointing to the negative.
No, that's a dumb question.
No, it's not. I would ask it.
It's totally fine. We're not debating on that. It doesn't matter. He now knows what to put it in.
Oh, it's because they're on the
It
same
starts
point.
up. When
Okay, does it actually show the entire line when you put this one in?
No.
No. Wait a second. What does it do? 4x minus 3 has to be greater than or equal to 0. 4x has to be greater than or equal to 3. X has to be greater than or equal to 3/4. The graph is starting at 3/4, at 0.75, isn't it?
Why?
Because you have a restricted domain, because you have a radical.
Yes.
So if you just give me this, and you box 4x minus 7, you are wrong. You have to say x has to be greater than or equal to 3/4. So what is this graph that comes out of this? It comes out the line 4x minus 7, but it has to start at greater than 3 or equal to 3/4. So if you ever have a radical embedded, and it squares it, and it gets rid of the radical sign, it still was there. You have to state its restricted domain. Now go to your Y1 and clear it out. And press graph now. That's what you should have. You should have the line at 4x minus 7 starting at 3/4. And if you don't put this and you just leave the 4x minus 7 into your calculator, does it actually just give you that part of the equation? No, it gives you the full line, didn't it? So star this. You have to know that when you have a square root that cancels off when you do compositions, this still exists. There's still this problem because at this step, I didn't get that line. I didn't get the full line. And this step matters. This is still the same graph as this graph. So if when you type in every line of what your work is, if you don't get the same graph the whole way along, you're wrong. So this graph should match my bottom line, so I have to restrict my domain to be greater than or equal to 3/4 to get only that partial line. So it only happens when you square a square root, because the square root goes away. If you don't square a square root stays, and you'll know that you're restricted domain, right? All right. What if I give you this? G of f of 3. I'll give you what the functions are in a second. F of 3. Let's go. See if you can figure out what you need to do. This one we're going to get G of f of 3. So even if I knew absolutely no grade 12 knowledge, say I didn't learn anything today, nothing happened. If I see f of 3 in grade 10, I would know what to do. What would I have to do?
X is 3.
Plug 3 into f and get myself an answer, right? Like even if I didn't have any grade 12 knowledge, I know to do that. So a lot of people get stuck here and they're like, I don't know what to do. But you do. In grade 10, you were taught how to do that, right? So go off to the side and find out what that is. So f of 3 is negative 3 times 3 minus 6, which is negative 15. So now I know f of 3 and negative 15 are the same thing. F of 3 is negative 15, yes? Whoa, my ponytail really moved that. So then I get g of what now? Negative 15, because f of 3 is negative 15. Do you see what I'm saying?
Yes.
Now we're in grade 10 again. What does this mean for us to do? Negative 15 into the g. So I'm going to get 2 times negative 15 plus 1, which is negative 30 plus 1, which is negative 29. And that is my answer. But guys, what did I find? I put in an input, and I got an output. An input and an output is a t-table. We get taught that in junior high, which means I put in an x and I got out a y, right? Input, output. Yes? So if I put in an x and I got out a y, what did I actually find? A coordinate, right? My answer is negative 29 if they ask what this is. But I actually, if they explained, what did I find? If they said to you, explain to me, what did you find when you did this? Well, you got a coordinate at 3 and negative 29. On what graph? G of f of x. That's exactly what you did. That's all you did. You got a coordinate, 3 and negative 29 on g of f of x. We agree? Okay, what about this one? So this is f of 3. Once again, that would look like this in the stupid form that you would have to change if you were given the stupid form. It would look like that. Do not fill in the dot and make the multiplication. So f of 3, we already found it out. It's over here. It's negative 15. So now I do f of negative 15. And then I plug that back into f. So I get negative 3 times negative 15 minus 6, which is 45 minus 6, which is 39. And that's my answer. But what does that 39 give? The y value of the coordinate. What's the coordinate? 3 and 39. What's it on? The graph of? F of x. That's all it is. Nothing crazy. Okay? Now, sometimes we're given something like this. This is f of x, this is g of x. These questions are actually easier. You guys think they're harder, but they're easier. So what if I give you f of g of 0? What's the first thing I would do? Rewrite it because this is stupid. So how would I rewrite it to? F of g of 0. So what's the first thing I need to find? G of 0. This is easier because g of 0 I would have just had to plug into the equation and do some math to get it, correct? G of 0 on here, I just go to 0, which is x, and find my y that goes with it, which is negative 4. So now I have f of negative 4. Now I go to negative 4, and I follow it to my f, and what's it going to be? Negative 1. Because your output is always y, your input is always x. This is easier than that. That actually defines the values by doing some math. This one I literally go to the x, find the y. That's it. Go to the x, find the y. Inputs are always x, outputs are always y. Right? T-tables. We've been doing this in junior high, I swear. I used to tutor junior high kids. And oh my goodness, do the same thing for like 4 weeks. It's like, can we pick something else instead of doing T-tables? We're really good at these now. Can we do something else? And a great father, and we did this, and we're doing this, and this, and this, and this, and this, and it's one lesson, and we're going to move on to more of something for you today. All right. What if I give you this? Last one. And then you guys are going to get the rest of the time to work on your thingies. You know, the thingies. The diploma thingies. Then you're going to work on the daily quiz, radical, radicals, other function things. You guys, we're going through that tomorrow. Okay. Shh. Last question. So say I give you h of x equals 2x minus 5 squared, and f of x equals x squared, and I tell you to determine g of x. Given h of x equals fog x, f of g of x. So here I fill in my h of x. I have 2x minus 5 squared. And then this f of g of x is just the same as writing, if I want to, f of g of x. And what does that mean? That means I'm going to put g of x, which I don't know what that is, in for f. We agree? So, okay. So we get 2x minus 5 squared equals, what is f? F is x squared, right? And x is g of x. So it's g of x squared. So what is g of x, if that's true? 2x minus 5. Because this matches this.
No.
Yeah. All right, so I want you to work on that diploma thingy I gave out to you. I'm going to hand you the multiple choice numeric response fill-ins, because you're going to fill them in so I can zip grade it quickly, because it's going to take me like 6-7 hours to mark the written response using a rubric. So you